Hi, welcome to the third lesson on the GCSE Physics particle topic. Once again, you're going to need a pen and a pencil for this lesson. So while you get that ready there, I'll get my screen shared. You're also going to need the worksheet that was attached to the lesson today. You can type your answers onto that and submit that back through Google Classrooms, or you can print it off and take photos of that to show us the work you've done today. So get the worksheet ready, get your equipment, get ready to learn. I'll share my screen. Okay, the title for today's lesson is Internal Energy. Make sure you've got that title written in your books and we're ready to go. You'll need the worksheet in front of you. And you can see the first activity we've got is again about solids, liquids and gases. I want us to think today about when solids, liquids and gases change from one state to another. For example, when a solid changes into a liquid, we call that melting. I melt a solid and it becomes a liquid. On your worksheet now, I want you to try and fill in the names of these different changes. So we know that changing from a solid to a liquid is called melting. But what are these other ones called? You might notice we've added one special one at the top here. Look where the arrow goes from and to. You've got enough to do now to finish off task number 1 and task number 2, filling in the names and answering question number 2. Do that job now. You can pause the video while you're working, and then we can mark the work together when you're finished. Okay, let's have a look at these changes between the different states, solid, liquid, and gas. Let's have a look. When a material changes from a liquid to a gas, we call it evaporating. Let's look at the cooling down changes. When a gas changes back into a liquid, we call it condensing. When a liquid changes to a solid, we call it freezing. Did you spot the name for the special change from a solid to a gas? That special change is called subliming. Some materials change straight from a solid to a gas when you warm them up. For example, you might have heard of dry ice. Dry ice is solid carbon dioxide. When it warms up, it changes straight from a solid to a gas. It sublimes. The name of the change is subliming. Give yourself a tick for each one you got right on your worksheet and do any corrections that you need to. You can pause the video if you need. Let's look at the next piece of learning. Now we've looked at this change between solids, liquids and gases, I want us to think about the energy that is in some solid, liquid or gas. The first type of energy I want you to think about is the energy these particles have, and we can get a clue from looking at what they're doing. In a solid, the particles are just vibrating. In a liquid, they are moving faster. They're able to move past each other and move in all directions. In a gas, the particles are moving very fast in all directions. There's a proper science name for the type of energy things have when they are moving. That type of energy is kinetic energy. We would say that the particles in a gas have a lot of kinetic energy because they're moving very fast. We would say that the particles in a solid have less kinetic energy because they are moving slowly. So in a solid, a liquid or a gas, there is some kinetic energy because the particles are moving. But there is another sort of energy stored in solids, liquids and gases that's harder to imagine. The total amount of energy in a solid, a liquid or a gas is called its internal energy. But the kinetic energy is only a part of that. What is the other part? Well, the other part of the energy is the energy stored in the bonds between the particles. A good way of imagining the bonds or the forces between the particles is to imagine the springs holding the particles together if you try to pull them apart. There aren't really springs there. It's just a good way of imagining it. If I tried to pull the two particles of a solid apart, the forces between them would try and pull them back together very strongly. If I tried to pull particles of a liquid apart, the forces that pull them back together are a little weaker. If I tried to pull particles of a gas apart, it's easy. There are no bonds or no forces between particles in a gas. So just like when I stretch a spring, there is lots of energy stored in the bonds or the forces between the particles. So that's what makes up the rest of our energy. Now, the energy in the bonds between particles is called the potential energy. So the total of the energy in the solid, the liquid, or the gas is called the internal energy. And the internal energy is the total of the kinetic and the potential energy added together. Potential energy in the forces between the bonds, and kinetic energy because the particles are moving. The total amount of energy is called the internal energy. Okay, from that, let's try and fill in some questions on our worksheet now. On the worksheet, we have questions about the amount of energy and the bonds between the particles. One word will finish off each of these sentences, different words for each sentence. See how many you can fill in, and then we'll mark them. Pause the video now and try and fill in as many of the missing words as you can that finish the sentences. Okay, let's have a look at the worksheet. In the worksheet, we have got the solid particles only vibrate, would get you a tick there. Liquid particles move slower. I'm sorry, liquid particles move faster than solid particles. Tick and tick. Gas particles move the fastest. And we say particles have kinetic energy when they move. Writing the order from the strongest to the weakest bonds. The strongest is solid, then liquid, then gas. The internal energy is the total of the kinetic and the potential energy. Doesn't matter which way round you wrote those two. The important thing to remember that the energy in a solid, a liquid, or gas is called its internal energy. And we get that by adding together the kinetic energy and the potential energy that's in there. Okay, so now we know what internal energy is. Let's have a look at what happens if we change the amount of internal energy in something. We're going to think about gas pressure, the force you feel when you try and squash something full of gas. For example, if you squeeze the tire on your bike, or if you've ever tried to squeeze a balloon, you feel the pressure of the gas pushing back against you. Where's that pressure come from? Well, it comes from the idea that the gas particles are always moving around. Gas particles are in constant motion. Because the gas particles move around, they hit the sides of whatever balloon or jar or container they're in. all those billions and billions of little gas particles hitting the side make a force. So you're feeling the force of all those billions and billions of little particles hitting the side of the container. That's what causes gas pressure. Before we start our work about gas pressure, let's go to the second side of our worksheet. Side of our worksheet has an internal energy question for you to try. Pick a word to fill in each of the blanks. One word in each space to finish the fact about internal energy. Pause the video and then we can mark the work. Okay, let's see which ones you got right. The total energy in a system is called the internal energy. Good job, give that a tick. It is made up of the total of the, you needed to get kinetic and potential energy in the system. Now, it doesn't matter which way around you wrote kinetic and potential, as long as you fit those two words in those two spaces. Particles have kinetic energy because of their movement. Good. And potential energy because of the bonds between them. Particles in a gas have the greatest kinetic energy. Good job. Make sure you've corrected those or mark them to show that they're all correct. Let's do our last job, our gas pressure job. Thought about the idea that gas particles make pressure on the container they're in because they're moving around all the time and hitting the sides of the container they're in. I've got a simulation which lets me look at what happens to the gas particles in a container when I make some changes. Let's pump some gas particles in and we can have a look at the pressure they cause. This simulation shows how the gas particles move around in all directions all the time. When they hit the side of the box that they are in, they cause gas pressure. I can see the pressure reading here is 71.8 because the gas particles are hitting the side of the box. But I'm interested in what could make that pressure increase or decrease to make the particles hit harder on the sides or not as hard. So we're going to make some changes. We're going to make changes, for example, like increasing and decreasing temperature. Each time I make a change, I'm interested in what happens to the particles. Do the particles move differently? Do the particles move the same? What do I notice the particles doing differently? And then I'm also interested in what happens to the pressure. Does the pressure increase or decrease or stay the same? So there is space to write these results on your worksheet. For example, to begin with, I'm going to change the temperature. I'm going to look what happens to the particles when I increase the temperature, and I'm going to look what happens to the pressure when I increase the temperature. And we can fill in our worksheet. Let's have a look. If I increase the temperature, what happens to the particles? I heat the gas up. I can see the temperature rising at the top. What happened to the particles? The particles moved faster. What happened to the pressure? The pressure increased. I can write that in my worksheet. When I increase the temperature, the particles moved faster. What happened to the pressure? The pressure increased. Why did that happen? Well, when I heated the gas up, the particles moved faster. That meant they were hitting the sides of the wall harder, and so the pressure was bigger. So you can see each time I make a change, you're going to have to write down what happens to the particles and what happens to the pressure. I'm going to make all the changes now, and you need to add your notes to your worksheet. By the end of the lesson, all the boxes should be filled in. Let's look at the next change we're going to make. We're going to decrease temperature. Remember, I want to look at what happens to the particles and what happens to the pressure. Let's see. Decreasing temperature. What happens to the particles? Particles move more slowly. What happens to the pressure? The pressure decreases. You can add this information to your worksheet, and I'll go through the other changes that you need to fill in as well. We're going to go through increasing volume, then decreasing volume. Increasing the number of particles, then decreasing the number of particles. Each time, add your notes to your worksheet. Okay, let's change the volume of the container. To change the volume of the container, I can make it smaller or larger. Increasing volume. What's happened to the particles? The particles have more space to move in, and they hit the sides of the container less often. That has made the pressure decrease. So increasing the volume meant the particles had more space to move in, and they weren't hitting the sides as often. The pressure decreased. Let's decrease the volume and make the box smaller. Decreasing the volume means the particles have less space to move in. They hit the side of the container more often, and the pressure increases. Decreasing the volume meant the particles had less space to move in, and the pressure increased. To make the next changes, I'll change the size of the box back to normal. Let's look at increasing and decreasing the number of particles. I'll add a different gas this time. Increasing the number of particles. If I increase the number of particles, there are more particles hitting the side of the box. What happened to the pressure? The pressure increased. Increasing the number of particles increases the number of particles hitting the side of the box. That increased the pressure. Let's decrease the number of particles. If I have fewer particles in the box, means less particles are hitting the side of the box. Less particles hitting the side of the box means the pressure decreases. So you should have all the boxes on your worksheet filled in. If you need to rewind the video to check any of these, you can. You have one last job. Underneath your results, it asks you to explain one of these changes. So you're going to need to write a because sentence. Explain why pressure changes in one of the examples above. So for example, you could write, when I increase the temperature, the pressure increased because. You can write an explaining sentence using the idea of the particles. Once that's done, that's all your work done for today's lesson. Make sure that you have the worksheets filled in and submitted before you click on submit to those, or you can take photos of your work and send that to us instead. Otherwise, we'll see you next time, and well done.